Good afternoon, everyone. Today I'm going to start by telling you a few horror stories about SMS-based authentication. And because we are trying to disambiguate the different acronyms that were listed in the talk title, I will explain that SMS stands for Simple Messaging Service. It's also known as text messaging. 2FA is two-factor authentication. SMS-based 2FA is the idea of getting a second code via text message to prove that you are who you say you are when you authenticate to a system. It's also an inherently risky way to authenticate, and I'm going to explain why. Back in 2016, California Representative Ted Lieu volunteered to have his cell phone hacked live on 60 Minutes. The hackers were able to get into the system, track his phone, not as exact as GPS, but actually track his physical location, and actually take complete control over his device. Now remember, this was a U.S. representative, and hackers were able to remotely take complete control of his device, intercept all phone calls, text messages, and anything happening with his handset, the same handset that he uses to actually conduct government business. It's a pretty terrifying thing to think about, but it's the same attack that can be used on your own handset, on your customer's handset, on other users who integrate with your application. So think about that, and let's talk about some of the weaknesses that actually allow that to happen that are all rooted in something called SS7, another scary acronym, I guess you can say. But before we get into that, I'm going to explain with a video a little bit more about the very specific risks around SS7. If anybody here uses Bitcoin, you've probably heard of the marketplace Coinbase, which is an online wallet where you can store your Bitcoin and then buy and sell, invest in cryptocurrency. It's a pretty cool trading platform. Several months ago, they got hacked. Not directly, but somebody was able to leverage the SS7 vulnerabilities to bypass all of their authentication and arbitrarily take control over any user's entire Bitcoin wallet. And I do have a 3-minute video just to show this. I will narrate as it goes through. I'm not going to do a live demo of it because that would be a crime, so I'm going to show a video of somebody else committing a crime instead. There we go. Okay, so in this case, the hacker is on the Coinbase website, and he wants to log in as another user. Coinbase uses email, so the hacker is going to try to recover the user's email address. Gmail allows you to look up your own email address based on the phone number associated with your account. If you put the phone number in, you can use an SS7 vulnerability tracker to actually intercept text messages that are sent to a cell phone. So given somebody's phone number, you get a text message, you intercept the text message, you can now take over the email address. Once they get the SMS text message, they'll go back into their hacking tool and get the code from Google. They can now put this back into Google's Gmail application to reset the password for an account, only knowing the name and the phone number of the customer. Once they put in the code, it now says, great, here's your email address. What do you want to do now that you know your email address? Well, now that we know the email address, let's reset the password, which is going to trigger another text message that the hacker can again intercept, type the code back into the platform. So waiting for, there you go, the second SMS has come through. Going to take that second SMS, put that into the platform, and this is going to now give the hacker complete and total control over this user's Gmail account, which by itself is pretty terrifying. But also, let's go ahead and wait while he resets the password and now takes control over Gmail. Okay, now the hacker is into the Gmail account. Hacker has full access, can do whatever they want to, which means they can go back into Coinbase and tell Coinbase, I know my email address, but I've forgotten my password. Please send me a password reset link via email so I can get back into my account. All of this was done using tools and technologies that are available for free on the internet. Anybody can download them. Anybody can buy the hardware that's useful. A few months ago, people were able to steal millions of dollars out of Coinbase that people had invested into Bitcoin using these attacks, because the recovery link just comes right through, and there wasn't really a way to protect it. Thankfully, since then, both Google and Coinbase have really beefed up security, so this hack is not actually executable anymore, but it was for a couple of years, up until this actually became public knowledge. So let's go on and talk a little bit more about SS7 and actually what makes this possible. SS7 stands for Signaling System 7. This is the infrastructure, the networking layout that actually powers all cell phone communication, text messaging, phone calls, video, everything across the United States, Europe, and through the majority of the world. It was developed in 1975 to make it easier for phones to actually switch back and forth. This is how one cell tower can transfer a call to another cell phone tower while you're driving down the freeway without you having to interrupt your phone call. The framework, though, has a lot of vulnerabilities. One of them being there is zero authentication in the platform whatsoever. Anybody can join the network and say, I am a cell tower, give me traffic. And the other cell towers just say, okay, great, we don't know who you are or what company you are. You could be Cricket, Sprint, T-Mobile. We don't care, we'll just add you to the network. And when you tell us that you have a customer attached to your network, we will forward you all of that customer's traffic so you can send it to their handset. It's a pretty terrifying implications there, because one of them is anybody can connect to the network and now query the physical location of any device elsewhere within SS7. So you can connect your fake cell tower to the SS7 network and say, where is this phone number located at? And the network will report back what towers that phone is located at, where they have been, and then when they connect to a new tower. This is accurate about 70% of the time, where just knowing someone's phone number, you can track them as they move around the country. In addition to that, once you advertise, now I have this phone number, this handset is connected to me, not this other cell tower, the other towers in the network will forward you all of the traffic. If any phone calls come in for that customer, you get the phone call instead of the actual customer. If a text message comes in for that customer, you get the text message instead of their handset. So think about what happens if you're using just text messages as your second factor of authentication, and somebody is trying to attack one of your customers. They can impersonate your customer on a system that requires zero authentication and steal every single text message that is originally addressed to that customer. So now that we're all properly terrified of how our phones work, let's talk a little bit about why this impacts SMS, because SMS is still something that is one of the most popular ways for people to implement two-factor authentication. Let's start with thinking about what the typical SMS flow is that we consider. You start with a user at their laptop. They authenticate. They give you their email address and their password, or a username and a password. However they authenticate, they tell you, your website, this is who I am, this is my proof, it's my password. Your website then calls out to Verizon and says, send this customer a text message so they can verify they actually have their phone. Verizon sends the text message to the phone. The user gets the text message, types it back into the website. You now know this user has identified themselves, has verified their identity with their password, and proven that they have access to their phone. This is the way we all think it works. This is a little bit of a more realistic example of how it works, because you might not be talking directly to Verizon. You might be talking to some SMS middleware like Twilio or Nexmo because you don't have a relationship with one of the big providers. So when you send that OTP, that one-time password to a customer to say, please verify who you are, you don't send it directly to the customer. You send it to Twilio. Twilio forwards it on to the next provider. That provider forwards it on to the customer. It's an additional hop, an additional party who's involved who might be able to somehow interact with that OTP, log it somewhere they shouldn't, manipulate it, what have you. There are a lot of different providers that you might actually be working with rather than talking directly to a mobile carrier. In addition to that, their phone might not actually be a phone. It might be a VoIP service like Google Voice or Skype. When I travel internationally, I use both Google Voice and Skype to text home because I don't want to have to deal with roaming charges that get really expensive in Europe. VoIP is a perfectly acceptable way to get a text message. But VoIP means you have other carriers in the loop. You have Microsoft forwarding messages. You have Google forwarding messages. In some cases, you might have Twilio forwarding a message to Google, forwarding a message to T-Mobile because you're using Google Fi or another one of these trendy new VoIP packages. You might also have another cloud service or application that's involved with actually backing up all of the messages that come through on the mobile device. There are a lot of other players in here that we don't normally consider when we think about we want to send a password to a user. There are also some malicious actors that might be involved as well. You might have a state actor either legitimately or illegitimately eavesdropping on traffic. If you've read in the news about police departments using stingray devices to intercept cell traffic, they're doing exactly what I showed you in that video. They're intercepting that traffic, reading text messages, and stealing phone calls. Once again, sometimes for legitimate reasons, sometimes for illegitimate reasons. If they're not a warranted government organization, there are other actors who have this technology who will be able to intercept these messages. Phone numbers can be redirected. Networks can be attacked, whether it be a wireless network, a Wi-Fi network directly, the cell network. Any of these networks can be attacked and can manipulate where the OTP is going, and it might not reach your customer. You could also just have an app installed on a mobile device that is stealing this traffic. There are a lot of apps that will try to smooth onboarding when you're actually signing up for a new service that will interact with the phone directly to grab a text message that comes in and populate a field and submit it to your server. It's a great thing to do when you have control over the app, and that's what you want to have happen. It's a horrible thing if somebody has installed a malicious app on your user's phone and is stealing these OTPs and trying to authenticate as your user. So now that we know that this is really what the OTP landscape looks like for SMS, it's a little bit more crowded than we thought it would be. It's a little bit more terrifying, and it definitely is not nearly as simple as this workflow here. That is the unfortunate truth for the way that text messaging works and the way that one-time passwords over text messaging works, and it is why NIST, the National Institute of Standards and Technology, has officially discouraged the use of SMS for a second factor of authentication. So let's talk about why, let's talk about some of the alternatives, and why, even as scary as this is, it might not be as dire as it seems. NIST announced their deprecation guidance last year, in the middle of last year, in one of their drafts, trying to say we don't want people using SMS anymore for a second factor of authentication. It made a bunch of waves when it hit. TechCrunch covered it pretty heavily, Wired covered it, a lot of other tech magazines started talking about why NIST was saying you shouldn't be using SMS, and rightfully a lot of people panicked. NIST published this new guidance at the same time a lot of different service providers had just finally started integrating SMS-based second factors of authentication. It was pretty worrying to see that that was going to happen, but then NIST later clarified who the deprecation was for. It wasn't for everybody. They were specifically writing the guidance for high security government installations where government users were being more readily attacked by foreign state actors who had all of these technical capabilities. It was not a general guidance for everybody, very specific subset. The other problem with NIST's announcement was that they used the word deprecate, which is a highly technical term that non-developers don't really understand. Deprecate doesn't mean you cannot use this ever. It just means it is a discouraged, not necessarily the best way to do something. When we write APIs as software developers, we deprecate different endpoints, different functionality all the time. It's a matter of saying, we have a new way to do this. We want you to use the new way. The old way still exists if you have to, but we'd rather you not. That's what NIST meant. So in their newest version of the guidance, their final draft, they've updated deprecation to mean just discouraged, because so many people panicked about how they weren't able to use SMS anymore. NIST just officially discourages the practice. It's no longer officially deprecated, which is just a subtle nuance to the language that they actually use, but it still helps us try to figure out what we need to do moving forward. So what do we do moving forward? What do we do now that we know that SMS is scary and people might be able to steal messages? There are some other technologies and other techniques we can use for second factors of authentication that we should be looking into. The first one is OOB, which stands for out of band. OOB is just another fancy way of saying there are multiple means of communication. To give you an idea of what OOB means, it's more than just security. It's not just two-factor authentication. Think about anybody who's coming to an event, anybody who's speaking at a conference. An out-of-band way to get your presentation ready would be to send it ahead of time, to email it to the conference organizers, to post it on Dropbox or post it on joined in, or speaker deck in advance of the event. That way, if anything happens to you, happens to your computer, or happens to your slide deck en route, the presentation is still there, is still ready to go. Or if you are sponsoring a venue, sponsoring an event, it would be sending your swag, all of your fidget spinners and t-shirts, separately via FedEx, so you don't have to check your bags and lose them when you get into Dulles International Airport. These are both different ways of a physical out-of-band transaction, where you have one mode of transit for the individual, the speaker, the presenter, the sponsor, and you have another mode of transit for their presentation or for the swag they're going to have in their booth. It just kind of gives you an idea of what I mean by out-of-band. The point is that you want to leverage multiple ways of getting things from point A to point B. You don't want to just rely on one. So you definitely want to make sure with SMS, you are typing your password and then typing another code that you get via a text message. It is an out-of-band communication. It does actually satisfy this, and it helps authenticate a user, assuming you don't have to deal with some of the other risks that are present with SMS. The other point of using an out-of-band communication is that it makes it much more difficult for an attacker to attack you. If you're using two different modes of communication for actually sending authentication information to the server, an attacker who wants to breach into your system needs to find a way to compromise both at the same time for the same user. If I know one person's password and I know somebody else's phone number, that doesn't do me any good. I might be able to guess this one password. I still need to get a text message from them to authenticate. If I know this person's phone number and I can intercept an SMS message from them, cool, but I don't know their password, so the intercepted SMS doesn't actually help. Splitting the different modes of authentication into multiple lines of communication strengthens things. Yes, we have discovered vulnerabilities in SS7, but as long as people are using password managers and using strong passwords, there's still added security there. There are ways around it. Out-of-band is just an additional way we can secure our systems. Some of the other forms of out-of-band communication that are not SMS are different forms of creating passwords, one-time passwords specifically. The first one is called HOTP, another fun acronym that we get to deal with in this alphabet soup. It stands for HMAC-based one-time password. HMAC is a hash-based message authentication code. So now we have an out-of-band HMAC-based message authentication code-based one-time password. Massive acronym that doesn't really mean too much. Just remember what the short letters are. The gist of this one is that it relies on a secret key that is shared between your customer and the server. This key could be a key that they know, but typically it's a key that they don't. Typically it is a strong key that you want to embed in some sort of a piece of hardware or piece of a software. The way HOTP works is by using this shared key and a counter, 1, 2, 3, 4, to generate a unique one-time password every time it's used. So you start with the counter of 1, and you start with your HMAC key, the secret key that is shared. You generate a one-time code, 6 digits long, 6 numbers. Type it in. The website can then verify it because they also have the same HMAC key, and they also know how many HOTPs you've used, so they can figure out what counter you're on to actually authenticate. And once you've used a one-time password, the server keeps track. The server doesn't let you use it again. So even if someone is able to figure out a code that you used yesterday to log in to check your email, it's no longer valid the next time. You can use a hardware token. You can use a software token. Software is typically a little bit better suited for other authentication methods, but hardware gives you some really cool looking military-grade encrypted tokens that you can use to actually log into banking systems, log into different vaults. Amazon, if you ever use Amazon Web Services, will allow you to actually purchase HOTP tokens that you can then buy and register with them. They will set up the shared key, and then you can type the number that you see on this physical hardware key every time you log into AWS to make sure nobody else is logging into your account and running up a $12 billion light sale bill. What was that? Yeah, that was just a single example, just showing a different hardware token. There are a lot of different ones out there. The next example is TOTP, which is very similar to HOTP, except it is a time-based one-time password. But it is also fundamentally identical to HOTP. HOTP uses an HMAC key that is shared between the client and the server. TOTP also uses an HMAC key that is shared between the client and the server. The difference between the two is that the counter used in TOTP is not just an incrementing integer. It's not just increasing 1, 2, 3, 4, 5. It actually uses the current time. It uses a timestamp. It divides it by 30 so that the clock increments every 30 seconds. That way you have a unique key that rotates, but it still uses a timer as a counter to make it a time-based token, so it's one that never repeats. You can't recreate it later. It's also available either in hardware or software. The advantage of using software instead of hardware is that you can update the firmware and keep the clock up to date without having to do anything fancy. If anybody here has used Google Authenticator, it's one of the leading examples of how to use TOTP to log into different systems. I use Google Authenticator to log into my mail, to log into Amazon because they will also allow you to use a TOTP software token. It's a really efficient way to actually get through to different systems. It's an open spec, it's an open specification, it's completely open source, and there is a reference implementation as part of the spec. So you don't have to invent it yourself, you don't have to understand how the code works. The specification itself comes with, here is exactly how you write the code to leverage time-based one-time password. Another form of out-of-band authentication is magic links, which isn't an acronym at all, it's just 2 words. But magic links allow you to send a one-time password via email. A lot of times you'll see this in the form of a reset token. I want to reset my account because I forgot my password. Each one-time password in a magic link is bound to a specific user. So it's not something where you can just log in anywhere within the system. And you can also use it as your first factor of authentication instead of even requiring a password because it is as strong as a password. The downside is it's only secure as your user's inbox. Think back to the Coinbase and the Gmail example that we went over earlier. Gmail could be secure if you use a strong password, but because Google they increased the usability of the system by making it easier to get back in, it became insecure. So Coinbase sending a reset link that allowed you to take control of an account into a Gmail inbox was actually a really insecure method of authentication. But there are ways you can make magic links secure. Slack, there is a Slack team for this conference. Slack uses magic links quite a bit. You can use those to log in. You don't even have to remember a password. It's fantastic. You just click a link and you get right into the system. I would also recommend, if you are using magic links within your application, to pair it with some other form of two-factor authentication, just so that you can prevent the risk of somebody's email getting hacked and then breaching your system that way. Using a TOTP token to also authenticate a magic link is a really solid way of making sure that the user is verifying they want to log in without requiring them to remember a password. Our next acronym is U2F. So we're back to acronyms for magic links. U2F stands for Universal Second Factor, which isn't very helpful. But it is an open standard by the FIDO Alliance, which is yet another acronym because everybody loves their acronyms. FIDO stands for Fast Identity Online because they decided to use 2 letters from the second word to make it a word that you could actually say. But it is an open alliance. It was established in 2013. There were a lot of organizations that were involved. Google has been involved. Yubico has been involved. And the entire point of U2F is to standardize the way you can use both a symmetric HMAC key shared between the client and the server and asymmetric keys that only live on the client to authenticate. I don't have a diagram of how the actual interaction goes, but it does leverage both. You end up having to sign a bunch of challenges, send everything back to the server can independently verify, and you end up having various hardware tokens that will allow you to authenticate into different systems. You can register the hardware tokens, use them as a point of authentication anywhere you want. It's also supported by almost every major browser, except for IE Edge, because Microsoft likes to not support things. You can buy the hardware tokens anywhere you want. There are a lot of different offerings. One of my favorites is YubiKey. Here's an example of a YubiKey FIDO certified U2F token. There are other providers out there. A hardware token costs something like $10 to $15. They're not very expensive, but they give you a very strong attestation of security when you're actually logging into a system. Another example of an out-of-band communication, another way to authenticate, is mobile push. And now I'm going to give you a bunch of alphabet soup all at the same time because this covers APNS, GCM, and SNS all at the same time. APNS stands for Apple Push Notification Services. If you use a Mac, an iWatch, or an iPhone, or an iPod, you've probably done something with Apple Push Notification Services when you get a notice that like Candy Crush has a new update or something like that. But this is also a way that you can authenticate because it is a secure system that is bound to a mobile device. GCM is what Android users integrate with. It is Google Cloud Messaging. It's how Google communicates both with Android devices and with Chrome OS and Chrome, not Chromium, but Chrome directly. They don't have it open sourced for people to use in Chromium-based applications, just in Chrome. SNS is Amazon's wrapper on top of both of them. To make developers' lives easier, we can integrate with one service, Amazon's Simple Notification Service, and then we can use that to send messages through both Apple and Google's interfaces. It will also work with Windows notifications for anybody who's on a Windows device or using a Windows phone or any other Microsoft technology, but Apple and Google are the two big ones that people use most frequently. The way push notification works is by sending a challenge to a mobile device. Every push-capable device has a specific push token that the service provider knows about. That push token is registered to your device and to the application on the device. So even if you swap a SIM card out, you can still get push notifications to your device. If you reinstall an application, you'll still get the same push notifications. It's only if you do an atomic reset of your entire device that you're going to lose connection with Apple or with Google. By pushing a challenge to the mobile device can then sign the challenge using a private key that only it knows and send the signature of that challenge back to the server. The server, knowing the mobile device's public key, can verify the signature and then allow authentication to continue. So it leverages a securely stored private key. If you're on an Apple or a Google device, an iOS or an Android device, you have a secure way to actually store credentials in your device. Apple's is called a secure enclave. I can't remember what Google's is called. I think it's just the Android key store. Both of them are hardware-based, which makes it very, very difficult to extract private keys. It is nearly impossible. I can't say it is impossible because there's been at least one situation where somebody has extracted a private key, but it required a team of like 30 people in a month to do that. So it is near impossible to extract these keys once they're embedded on the device. Mobile push is actually used by a lot of different organizations today to power authentication. A good example is Google, which uses their new Google Prompt service to allow you to authenticate to other Google services, assuming you have one Google service already authenticated on your device. You install Google Search on your device, you can now authenticate to everything from Gmail, Google Music, the App Store, everything you need to, because you'll get a push notification from Google asking if you want to authenticate, because it already knows you're authenticated by some other means, and it's just verifying you are doing what you want to do. Another one is a product called LaunchKey, which is part of iOvation. They use push notifications for authentication as well. They have an SDK that you can install into PHP and other language apps as well. It's really great. They have a mobile app that they use, kind of like how Google uses any of their apps for push. LaunchKey uses their app for push as well. I would be remiss if I didn't mention it, but Tosni also has our own mobile app that does the same thing. It's just another offering. There are plenty of providers that are out there. So let's talk about some of those other providers. Auth0 is a great provider for different developers who want to integrate with different things. They power magic links, they power SMS-based authentication. You can integrate any platform you want with them. They will help you set up email templates, configure how you're actually going to distribute messages to your customers. They have plenty of tutorials out there and developers who are standing by to give you a hand if you ever need one. Authy is an app that also gives you this similar kind of functionality, and they will do different authentication from a mobile app to a server. They make it incredibly streamlined and very easy for users to work with so that they don't have to be developers to understand what's going on. Duo is one of the more popular two-factor push-based authentication apps that are out there. A lot of people tell me that they love Duo. They build their entire business on Duo. Depending on your uses, they have kind of not a super expensive plan, but if you are a service provider offering subcontracts for hundreds, thousands, or millions of customers, you're going to have to work with them directly to negotiate kind of a bulk pricing. They're targeted more towards consumers who want to authenticate rather than developers or agencies who want to build authentication solutions for others. If you wanted to work as an agency and build something for someone else that's white labeled, you'd want to use Auth0, LaunchKey, or one of those other providers who would give you that additional functionality. Additionally, Yubico, as I already mentioned, YubiKeys and FIDO YubiKeys are one form of authentication. Yubico also provides other hardware tokens that allow for further authentication. A standard YubiKey, which costs about $50, will do FIDO U2F authentication. You can also do, not push-based notification, but you can embed RSA keys to actually do RSA challenge response-based authentication. They also support TOTP and HOTP, all inside a hardware token you can buy for $50 and just plug into the side of your laptop. Those are just a few providers. There are lots of providers out there. The authentication market is a relatively untapped space, so there are new providers coming out all the time. These are just the big ones that you should keep an eye on if you're looking to integrate any of this into your applications to enhance security for your own users. But let's keep a few things in mind before we end today, just to talk about a couple of things as we're remembering. We started with acronyms, and we started remembering how NIST has deprecated SMS as a two-factor authentication scheme, generally, but more specifically for their own government use case. Remember, it's a recommendation, not a requirement. The deprecation is just discouraging you from using SMS. It's not saying you can't. It's not saying you're not allowed to. There is no standard that says it's banned. There is no standard that says it's prohibited. There are just standards that say you should probably consider using something else. That being said, if you're using SMS for two-factor, it's better than not having any two-factor authentication at all. The chances of you being attacked by a nation-state actor or being directly attacked by somebody who has the technical and the hardware prowess to actually integrate with the SS7 platform and try to steal steal SMS notifications is pretty low. It's something that you're probably not going to have to worry about unless you're dealing with state secrets or high-level confidential information in the first place, just because it does take a lot of money. It does take a lot of hardware. SS7 is exploitable, but it is incredibly difficult to exploit unless you know what you're doing. There are probably more people in this room today than there are who are going to actively exploit this right now, so the chances of your users being targeted is incredibly, incredibly slow. Also remember, all of the providers I've talked about, every single one of them offers an SDK, except for maybe Google. They claim they offer an SDK, but I haven't been able to find it. They don't link to it anywhere, but they do say it's available. But every other provider offers an SDK. Use their software development kits. Use the tools they provide. Don't try to build your own. Don't try to talk to the APIs directly. Don't try to reinvent the wheel. The service providers know their platform better than anyone. They will be able to help you navigate any pitfalls with their system without you having to figure it out on your own. Use their systems, use their SDKs, use their documentation, and ask them for help if you get stuck. Don't try to figure it out on your own, because that's when you might make a mistake, and it might cost you or your customers a little bit of security. Also, when it comes to authentication, never reinvent the wheel. I work in cryptography, and we tell people all the time, when you're working with a crypto system, you never want to invent your own crypto. You never want to invent your own algorithms. You always want to use something that is open source, has been well verified by the community, has been openly audited by an independent third party. When you're working with authentication, follow the same rules. Don't come up with your own password hashing scheme. Use the password hash function that exists in PHP. Don't come up with your own storage scheme. Use the storage schemes that have been pioneered by other people. Don't come up with your own fancy two-factor authentication system. Use one that somebody else has built. Unless your business is authentication and building two-factor authentication, you probably have other things that you should be focusing on in order to make money. Focus on those things and hire the people who do this for a living, because they're going to spend far more time making sure they get it right than you can probably afford to. Those are the tips that I have for authentication. A little bit about me. My name is Eric. I work for a company called Tosney on the West Coast. We focus on identity, privacy, security, and encryption solutions, specifically toolkits for developers. We're sponsoring this event. We have a booth out there in the lobby. I'd love to talk to you about more of what we do, show you some demos of what we do, and just answer any other questions you have about our business, but more about this event and more about this talk specifically. Does anybody have any immediate questions right now? really no questions. Well, feel free to ask any of them. We can take a few. We've got time. Yes. For those on the recording, I mentioned Google Authenticator. Is that a preference over the other ones? That is my personal preference. There are plenty of other authentication apps out there. Google has their authenticator app. Apple at least used to. I wasn't able to find it the other day when I was looking for it. Microsoft has their own authentication app. When you're dealing with authentication apps, pick one from a well-known provider. If you search on the Apple App Store, because I was looking for this for someone yesterday, and I searched for Authenticator, Google Authenticator was the second option, and all of the other options included ads and were by other people that we had never heard of before. Those might work, but I don't trust an authentication app that A, includes ads and code from a third party that I don't actually know to not be leaking my data to someone else. Google, you can probably trust. Apple, you can probably trust. Microsoft, you can probably trust. Any of the providers that I listed here are providers that have been proven in the market. They've been around for a while. If you find somebody else who's like an authentication app that integrates directly with Angry Birds, unless it's written by Rovio, I wouldn't trust it. So just make sure that you're vetting who the provider is before you install it. Yes? Okay, so the question for the recording was, a lot of these solutions are for personal authentication. What is available for application level authentication and key management, credential management? There are quite a few other solutions out there. I didn't get too far into them because they weren't directly related to interactive two-factor. When you are dealing with specific credentials management, one really good solution is a product called Vault by HashiCorp. They're the company that makes Vagrant and a bunch of other solutions there. It will manage your credentials for you in a sealed, completely encrypted way, and then you can directly manage who has access to that based on certificates that are actually stored. Some other solutions that get into the really low-level developer weeds are like CredStash. CredStash is a command line utility that leverages Amazon KMS, which is their key management service, and Amazon's DynamoDB to encrypt credentials and store the encrypted value in a table, and then you can pull those back out when you actually need them. There are also tools like GitCrypt, which is a utility that integrates directly with a Git repository and allows you to have like a flat file of your credentials in your repository that is encrypted with your RSA public-private key pair. So you can view it, and then you can authorize, let's say, a server to be able to decrypt it, but anybody else who gets a hold of the repository wouldn't be able to view it. There are a lot of different solutions specifically for credentials management for embedded systems, but a lot of them are very niche to deal with specifically with how the application is deployed and what kind of credentials you need to manage. The name of the tool for Git was called GitCrypt. Yeah, it's just a command line utility that leverages public key infrastructure to pull credentials in that way. It's really useful for managing a secret zero. So if you have an application that wants to use a tool like CredStash to integrate directly with Amazon KMS and decrypt credentials that way, the application still needs an AWS credential to talk to AWS. So you might have an AWS credential rooted in the application, encrypted by GitCrypt, unlock that credential, and then use that to talk to KMS to get other credentials that you need for the application. Yeah, you're welcome. Any other questions? Yes? Okay, so how would this connect with OAuth, OAuth 2? Those ones are more for, I don't want to overgeneralize, but those are typically more for shared authentication between different services. So you might have one system where you have to authenticate to it and use two-factor authentication to verify first, and then once you're authenticated, then you'll have an OAuth 2 token or an OpenID Connect token that you can send to another third party to authenticate there as well. So all of these services aren't necessarily directly integrated with OAuth because that's more an identity exchange and attestation system. These are more for how you would authenticate into the first system before that system verifies your identity and promises that you are who you say you are to a third party. Any other parting questions? Cool. Well, thank you very much, everybody, for coming. Once again, I will be out in the lobby if anybody has any other questions they didn't want to ask here in the group, and I'd love to talk to you about what you're doing for authentication. Thank you very much.